So as you know that we are discussing about microcomputer. Here the main CPU is the microprocessor. So already we know we discussed about the microprocessor in the previous lecture series. So now here let us we are going to understand in detail about this processor microprocessor. So here this microprocessor may be a 8085 microprocessor or 86, or it may be 80386, or it may be a 586. So we have different microprocessor that designed from 8-bit to 128-bit microprocessor. So here the each microprocessor is having specific registers and a particular ALU, its power capacity, address lines, everything will be depend upon the particular processor. So now we are going to discuss about the particular 8085 microprocessor. So here we are going to discuss about 8085 microprocessor. This 8085 microprocessor is a 8-bit microprocessor. It means that at a time is going to perform 8-bit arithmetic and logical operations. It is designed by Intel in 1977 using an NMOS technology. This is the technology they are going to use, like N-channel metal oxide semiconductor technology. Even we have CMOS also, like combination of both the PMOS and NMOS. It is CMOS. So first they are using the NMOS technology at the beginning they used. Now it is used in many applications for embedded applications like washing machine, microphones, mobile phones, many more. So it is the following configurations. So this 8085 microprocessor is having an 8-bit data bus, 16-bit address bus. So to communicate from processor to memory, it requires buses. So data bus used to carry the data from processor to the memory or from memory to processor. And the address bus is used to send the address of the location. This is one directional from processor to memory or IO device, not from memory to processor. So it is a 16-bit unidirectional bus, but data bus is bidirectional. So if it is a 16-bit address bus, it can have maximum address up to 64 kilobytes. Means 64 kilo memory location. Each memory location is of 8-bit capacity. Then a 16-bit program counter. 16-bit program counter capacity is 16-bit. So the address of the instruction will be stored in the program counter. Then stack pointer is of 16-bit. The address of the memory location that is used for stack, the RAM memory location, part of the RAM memory can be used as a stack. So there we are going to store data, and also whenever there is a subroutine to be executed, the return address also to be stored in the stack. So that memory location address will be stored in the stack pointer. Then we have 6 8-bit registers. They are in pair B, C, D, E, H, L. You can use in pair also. They are arranged in pairs. So each is of 8-bit capacity. Each register is going to hold the 8-bit of data. Then it requires plus 5 volt DC power supply to operate. And the operating frequency is of 3.2 megahertz. So now let us see in detail about the architecture, its internal block diagram. So it consists of main units are ALU, timing control unit, and register. As we have seen in the block diagram, we have ALU, register set, and control unit. So this is the ALU, arithmetic logic unit. It performs arithmetic and logical operations on a given data. So data will be from accumulator and from other, it may be register or memory location, but it will be internally stored in the one of the temporary register. And one data always it should be an accumulator. So content of these two is going to perform the specified operation, any arithmetic or logical operations. After performing, the result is once again going to store into the accumulator. So here there is a flag register is there that depend upon the result. the status of the result will be reflected in the flag bit. As we know, there is zero flag, carry flag, sign flag, parity flag. So according to the result, these flag bits is going to change the state, either 1 or 0. If all bits are 0, for example, then 0 flag become 1. If there is a carry generated while addition, at the MSB bit, if there is a carry generated, then carry flag become 1. So like this, that is a function of flag. Then we have register set, as I told you. These are W and Z are temporary registers. These are not accessible to the programmer. And we have P, C, D, E, H, L. These each is of 8-bit capacity. Means each is going to store 8-bit of data. Then we have stack pointer. It is of 16-bit capacity. Then program counter we have 16-bit, as already told. It is a function. Then also we have increment and decrementer to increment the program counter or decrement stack pointer. These functions will do. This hardware is there. Then we have address buffer, address or data buffer. We have address or data buffer, means it's a combinedly address and data buffer. Okay. So this is a address bus A8 to A15. Then AD0 to AD7 is address as well as data. The timing is different. First, always we are going to use an address bus. Next onwards, we are going to use the data bus. So always we need, whenever you want to read or write the data from memory location, first you need to identify the location. For that, we need address. Then later on, we need data bus. So that is the reason, first part, while performing the operation, we are going to use that same bus as an address. Then remaining time, we are going to use as a data bus. So then we have here instruction register. So the program is stored in the memory. This is the processor. Processor will read the one by one instruction from the memory. That is, reading is called the fetch. Then after reading, it is going to store first in the instruction register. Then it will send to the decoder. It is going to do the decoding function to know the actual function of the operation. And also, according to that corresponding, the device will be enabled, corresponding control signal will be generated. After decoding, the corresponding control signal will be generated by the timing and control unit. Then it is going to perform the last function is execution, performing actual operation, that is called execution. So actually there are 3 steps: fetch, decode, execute. For every instruction, it has to read from the memory to the processor, then to know the actual function, and corresponding device has to be enabled and corresponding control signal will be sent, that is called decode function. Then to perform actual operation is called the execution. So then, as I told you, the timing and control unit is going to generate time signal clock, and also it is how control signal read write ALE. Then either read or write function, for that it is required. ALE address latch enable to latch the address. As you know that address and the data bus combinedly is going to use. With the help of ALE, we are going to store the address in a latch. Then later part we are going to use the same bus as a data bus. With the help of ALE, we can demultiplex address and data signals. Then we have status signal S0, S1, IO memory. These required to distinguish the function, is it memory read or memory write, IO read or IO write function. The corresponding control signal will be sent to the respective devices. And we have DMA, direct memory access. This is used to transfer the data from one device to another device directly without the intervention of the microprocessor. See, instead of using microprocessor for every step of operation, we can make the microprocessor to do other function. So meanwhile, the DMA can take control over to transfer the data from one device to another device. For that, it is required address, data and control buses. These are all controlled by the processor. So first it is going to send one signal, hold signal to the processor. It means that it requires buses. So once the processor receives the hold signal, then is going to give the acknowledgement signal. Yeah, I am ready to give the address data bus. Then once the DMA will receive HLDA signal, hold acknowledgement signal, then start transferring the data from one device to another device. So then we have serial IO control. So this is a control device. is used to convert from 8-bit data to bit by bit serial form, parallel to serial. So here the data can be transferred from processor to the other device in serial form through this line SOD, means each time 1 bit will be transferred. Then it is also going to receive the data in serial form through this line, serial input data. So now we have interrupt control unit. Interrupt. This is going to take care of the interrupt functions. So more than one device can interrupt, and you have more than one interrupt signals. So depend